Good morning, good morning, good morning. I hope everyone is happy and healthy and doing fabulously. We are going to continue a unit on proportions within similar triangles. So this is the last of our chapter 8 content, and I hope this seems to make sense. Really, this is just 4 theorems that apply to these situations and where they're coming from and how to use them. So we are going to be asking you to use similar triangles to solve real-world and mathematical problems. So what I'm going to ask you to do is to apply the correct theorem to each problem type. And it's going to be that you just need to recognize what the theorem says to do. And then set up and solve a proportion involving triangles. So what is this problem asking us? Okay, so if a line is parallel to one side of the triangle, so what we're looking for here is that this line has to be parallel to one side of the triangle. So when you're looking for Theorem 8.4, you are looking for a line with a little arrow on it that indicates that it's parallel. You can see what's different about 8.5. There's no little lines here. And so we're looking for a triangle that has a parallel line inside of it. So if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. What does that mean? Well, that means that QR matches up with QT. And it means that RS matches up proportionally to TU. And that those are equivalent proportions. So QR is RS and QT matches up with TU. Or you can set it up differently. You can set it up where, so we have QR and RS, and then this is QT and TU. So either of those is what you're going to set up. And it's simply saying, hey, they're proportional. That means you can set it up and solve it. Okay, Theorem 8.5 is the converse. So remember that the converse flips our hypothesis and conclusions. So it flips our if and then statements. So a line divides two sides of a triangle proportionally. So if it divides them proportionally, then the line is parallel. So this is used to prove if the line is parallel, if the line is parallel to the sides. So if, say this is 6 and this is 8, and this is 4, and this is 12. Nope, not 12. We'll go with 6. Let's see if that works. Okay, so we have 8 over 6, specifically this 8 over this 6, and then this 6 over this 4. So we're going to do the top side over the bottom side. Then 6 corresponds with 4. So if these are proportional, then it is parallel. So if this is 36 and this is 32, oh, it's not proportional. So what would the side length need to be? Well, this 8 would actually need to be a 9, and that would make it proportional. Because that would make it 36. Now, if that's the case, if those are the measures, then yes, the lines are parallel. So if it's proportional, then the lines are parallel. So on this particular one, we're proving if the lines are parallel. In Theorem 8.6, it says 3 lines intersect 2 transversals. Sorry, 3 parallel lines. So we are looking at these 3 parallel lines. And we have 2 transversals. Then what we're saying is they're dividing the transversals proportionally. So between U and V and between V and W is proportional to XY and YZ. Or we can set up the proportion differently. We can set it up where with our little short sides together. So we have UV over XY is equal to VW over YZ. Either one. But basically it's saying that they are proportional. So what we look for here is 3 parallel lines. So we're going to identify 3 parallel lines. So again, to know this, we're looking for 3 parallel lines. And then we're going to set up the proportion where we have the small sections are equal to the bigger sections. Pretty simple. Okay, and Theorem 8.7. So a ray is a line that has an arrow on one end and ends at a point. So a ray bisects. Bisects means that it cuts it in half. Cuts it into 2 congruent places, which is why you can see here that we can see that it's the ray AD has bisected angle A because it is in 2 equal parts. Then it's saying that, hey, BD excuse me, and DC are going to be proportional to AC and AB. So you can match up AB over BD, and you can match up AC over CD. Or you can match up the long to the long, so it's AB to AC is equal to short to the short. So on this one, you're looking to make sure that both of the angles have been segmented. So again, the first one, you're looking to make sure that there's a triangle with parallel lines inside of it. Then you know you're going to set up Theorem 8.4. 8.5, it's going to have the line, but there's not going to be the parallel side marked. This one is proving if they are parallel. 8.6, you are looking for 3 parallel lines that have been crossed by 2 others. And for 8.7, you are looking for a triangle, and one of the angles has been split in half. So the directions are, for each problem type, determine the correct theorem that will apply to your problem and justify your reasonings, and then correctly set up and solve the problem. Okay, so for A, for number 1, what I see here is I see a triangle with 2 parallel lines. That means I am looking at theorem 8.4. So it says, and justify your reasonings. So this is theorem 8.4, and B/C is my shorthand for because. There are parallel lines marked. That's my justification. Now, I can tell you that you're not going to use 28. And to find this length, you're going to do 36 minus x in order to determine it. And this one would be x. So all I want you to do is set up the proportion. So that means that 27 over 18 is equal to x and 36 minus x. And then you should be able to solve that proportion. Question number 2. Okay, I see a triangle, I see a line, but I don't see that it's marked as being parallel, so I'm going to be using theorem 8.5, and this is where I need to determine if WY is parallel to VZ. And how am I going to do that? Well, I have 3 over 6 and I have 4 over 7. And 6 times 4 is 24. 3 times 7 is 21. Are those two equal? Then it is not proportional, which means it is not parallel. For number 3, I see 3 parallel lines. 1, 2, 3. So if I've got my 3 parallel lines, I know they're dividing it proportionally. So I have 8 over 6, and I have 10 over x. And then I solve this to find my value for x. For number 3, I also need to state which theorem, which is 8.6, and justify. 8.6 because there are 3 parallel lines. Okay, and number 4. Well, on number 4, I see 2 angles that are equivalent. So I'm looking at theorem 8.7. And why am I using 8.7? Because the angle is split in half. Angle B is split in half. That means 5 over 3.5 is proportional to 12 over x. And again, I solve this by multiplying and then dividing in order to finish this problem out. Number 5. I see 3 parallel lines. 1, 2, 3. And they're crisscrossed by 2 others. That means I'm using theorem 8.6. Why? Because I have 3 parallel lines. And I've got 2 proportions to set up here. So I'm going to set up the first one with 1320 over 2380. Well, I've got the piece for x. So 1320 matches up with 2640. So 2380 is going to match up with our x. And then we're going to use the same measures again and match it up with y. So the 1980 is going to match up with the 1320, and the y is going to match up. And again, you simply solve these in order to determine the values. Question 6, I see an angle split in half. So that means I'm using theorem 8.7 because angle E is split in half. That means that between G and F, this is going to be 14 minus x. So we have 8 over x is equal to 12 over 14 minus x. Now let me go ahead and solve this one for you since I haven't solved one in a little bit. As a reminder, you do this times this and this times this. X times 12 is going to be 12x is equal to 8 parentheses 14 minus x. Now remember, we have to distribute. So 8 times 14, that's 32, carry a 3, 112 minus 8x. Then we have to move our variables to one side. So we're going to add 8x to both sides. So we're left with 20x is equal to 112. Divide both sides by 20. X is equal to 112 divided by 20, which 55.6. Yep. All right, and the last one. So this one, I see a triangle with a line inside of it, but I don't see any statements that they're parallel lines. So I'm using 8.5, and I'm doing that to determine if DE is parallel to CB. And so I set up the proportion. I have 18 over 6, and I have 24 over 8. And again, if that's proportional, then they are parallel. So if this times this, which equals 144, is equal to this times this, which is also 144, then we know that yes, DE is parallel to CB.